Next one. Okay, these requirements that you need to put in. Okay, the instruments must exhibit strong correlations with the variable that you want to instruments, but it cannot be correlated with derivative. Now, you have to identify that instruments. Okay. So, in one study that people have done, for examples, they look at, these are very interesting study. I just want to give you some appreciation of what instrument means. Right? One study that try to do, right? They try to look at, see, I love to use the economic growth examples for whatever reasons, right? So I have economic growth examples, right? So this one study has been done. They try to look at whether economic growth is affected by trust in society. Okay, so they have measurement of trust, and then some other control variables that you could want to put in, and these are the key variables. And the argument that the author makes is that this variable is endogenous. Right? There are various reasons for endogeneity. I will discuss at the end what are other reasons for endogeneity. They said this one's trust is endogenous. Right? So what you have to do in order to estimate, you have to come up with the instruments. Using instrumental variable technique or using two-stage least square. So he have to find another variable x that are correlated with trust but not correlated with derivative. Right? And these are country data, country level data they use. Yeah. So the proxy that they get, right, they look at the country. Right? And the trust, they use dummy variable for instruments. Right? And very interesting part, they look at whether the country is rice-based or wheat-based. The reason very simple. In terms of paddy farming, you cannot do alone. Normally you do in groups. You do through community. Menuai bersama, menanam bersama, and so on. So this society have more trust. Wheat, you can grow on your own. Because wheat is quite wild in terms of plants, which means less cooperation needed. Right? So he think that this society, the way they depend on rice or wheat, can be a proxy for trust. But this has nothing to do with derivative. Right? Economic growth doesn't, see, economic growth can affect trust. And these are one source of endogeneity we call reverse causality. Right? The more that the economy grows, sometimes people become less trustworthy, right? Or become more trustworthy. So which means growth can affect social values too, right? But growth will not affect whether society will adopt rice or will adopt wheat, because these are exogenous in the first place. So they use this. So the main problems in instrumental variable, are you able to get instruments? You see, these are not easy to get. Only in few articles they argue in this way. Right? They argue in this way. Right? That this can be a good proxy for trust, a good instrument for trust. Right? But when it comes to, no, I explain this just to let you know that finding instruments is not easy to get the instruments. Right? For examples, other study they have done, they look at Islamic financial developments, let's say. Now, are you sure this one is exogenous because the way Islamic finance develop also depends on the country's growth. There exists reverse causality. So this can be endogenous. But how to find the variable that are not related to this? Right? You said, okay, let's use religiosity. But economic growth can affect religion value too. It's not good proxy. It's not good instruments. So it's not something easy. So in literature, when it comes to financial developments, what do they use? They use law of origins, whether you are common law or civil law. Yeah, they use those. So sometimes it's not easy. But I try to bring you to the appreciation of the fact that when it comes to GMM, finding instruments has been made easy for you. Right? In order to get instruments made easy. Normal econometric modeling, finding instruments is not easy and sometimes extremely difficult. And when people use two-stage least square, still difficult, and there are certain conditions that must be fulfilled. But when it comes to GMM, I would say that the one that developed GMM is very genius in looking at helping us to get the instruments without having to search for the instruments.
Is it the internal instrument?
They use exactly internal instruments. Right? You don't have to go to, here they use external, they go to outside the variable there. Right? They use law of origin, they use whether rice base or grain base to be the instrument, they use outside instruments. But GMM allow you to estimate by using what we term as internal instruments, right? So the way that GMM do is basically in the first steps, if you look at, I will try to explain to you later on here, they do not in two steps. There are two stages of estimating. The first one, they filter out the individual specific effects. And they filter it out. Now, there are many different ways to remove this. There are many different ways to remove this from the equations. Right? And I know of 3 different ways to remove those from the equations. Okay? And when you do fixed effect, how do you remove this? Fixed effect panel model. We remove using what we term as within transformations. So which means you take YIT minus with the means of Y for a unit I. Right? So you do within transformations and you remove this. Now, in dynamic panel models, we remove this by taking the first difference. Right? So what do we do? As I done before, we have YIT equal to theta YIT minus 2 plus delta XIT minus 1 plus mu I plus VIT minus 1, right? I lack 1. Take the first difference.
Sorry. So I can use, I say, if the superiority of DMM means I can use the level and difference equation for the unity problem.
Okay.
See that or
Step by steps. We're coming up to your case, right? We'll come up with your case. We go step by step. Right? Now, see, the first step in GMM, we remove individual specific effects. Remove doesn't mean it's not there. It's there. Just filter out. We are not interested in this value. We are interested in this value, right? So why bothering putting this one here? So basically, we transform first, and the transformation is by taking the first difference. So when we take the first one, minus with second one, we get what? We get yit minus yit minus 1. Right? And we get theta yit minus 1 minus yit minus 2. Right? And we get delta xit minus xit minus 1. And mu I minus mu I equal to 0. So we remove them. Right? And then we have VIT minus VIT minus 1. So this would be the transform equation that we use in order to extract the value of theta and delta here. Right? So we take the first difference to remove them. But by removing individual specific effect, it will still not resolve the endogeneity problems, because there still exists correlation between derivative term and independent variables. Right? Now, you can take a look at here, for examples. There will be a correlation between this and this. Right? Still correlations between this term and this term. Why do you think that this and this are correlated? Because yit minus 1 depends on vit minus 1 in these equations. Yit minus 1 depends on this value, and as a result, this term depends on this value. They are correlated. So we still have correlations. We still have endogeneity in there, despite the fact that we have removed the individual specific effects. We still have the problems. Right? Now, how to solve them? Instrumental variable for this. Right? Instrumental variable for this. So how does it work in terms of getting what we term as internal instruments? Right? Now, if you know exactly the theory, you can count the number of instruments. When you run estimation, you will see instruments that are reported with what you count will be exactly the same. Right? So if you look in terms of this case, for example, here, they are still correlated with this. And estimation with this endogeneity problem using least square estimation will still be biased. As a result, we have to identify the instrument for this. Okay? How does it work? Let's take a look at the explanation. How does it work in terms of the instruments? Right? Now, to make it simple, I do not put X in there because we assume X exogenous. Putting there, not putting there, do not make a difference in terms of demonstrating the instruments that we use, right? You have this, right? Your models. Just take X out there. These are your common error term which have both of them. And when you filter this one out, you get this, right? Which is exactly what I'm written here without this term, right? Exactly the same. But here, delta, exactly the same, right? Now, the problem, as I mentioned, there are correlation between this term and this term. Why? Because yit minus 1 depends on vit minus 1. Right? Remember this one? Right? Yit minus 1 depends on this value, because this one is broken up into this component, this component, this one, this one. So, which means that vit minus 1 is correlated with this. Right? So it means that this terms here is correlated with this. You still have the problems. Right? Now, if I ask you for examples, right, what type of the instruments that I can use that are correlated with these terms, but not correlated with this? Right? What is the instruments? Find some internal value or the internal variable that are correlated with this term but not correlated with this. Okay? Now, the answer very obvious if you think a little bit more in terms of this case. Why not I use y I t minus 2 as the instruments? Okay? Because yit minus 2 will surely be correlated with this because in this term contain yit minus 2. Right? But yit minus 2 will not be correlated with this because yit minus 2 is the value from the past which already have taken place. Right? So yit minus 2 have already taken place and vit, this error term, follow classical assumptions. So it doesn't depend on the past value because if the error term depends on the past value of y, then the error term doesn't fulfill classical assumption in the first place. So whatever have taken place in the past at it minus 2, right, will not affect the error term this year. Apa yang berlaku yang last year will not affect error term this year because that already have taken place. It's not some shock that happened that will cause error term to increase or decrease. Right? So that's why sometimes when you read, they say we use the level variable to instrument the first different equations. Right? And that level variable that had been put in. Right? Now, if you want to use this as a way of doing instruments, and when you do panel data, there exist requirements. For any unit, there must be at least 3 years. Right? There must be at least 3 years for you to use the instruments. Now, why 3 years? Right? Let me show you in terms of 3 years.
Can I ask you?
Yeah.
You mentioned yt minus 2. This one is to replace yt minus 1 here.
To replace both of them. To replace this.
Delta. Replace delta.
Yeah, no, to replace this. The first difference.
The first difference.
Yeah.
Not to so not yt minus 2 minus yt minus 3.
No, yt minus 2 only. Because yt minus 2 is correlated with this. With all of those through this component. Okay. So you have to find some variable that are correlated with the endogenous variable, and endogenous variable is the first difference. And you look at in this way, right? See, when you run the model, right? You have year 1, year 2, year 3, year 4, year 5, and so on, right? And then you have your y, your x, and so on, right? Now, when you take the first difference, the first year will be lost, right? Why? Because you get y2, right? Y2 or yi2, year 2 minus yi1. When you take the first difference, the second year minus the first year, right? Equal to delta yi1 minus yi0. And you look at in this case, this year also cannot be written. Why? Because you didn't have the value i0 there. Right? So when you transform, the starting point will be 3. Right? So that's why you have to have at least 3 years for each cross-sectional unit. If you have 2 years, it means exactly the same, you have not put that unit in. Because when you take the first difference, if you have 1 year, of course, you cannot take the first difference in the first place. Right? And you have 2 years, you don't have yi0 at time 0 here. You don't have data before this. Right? So start with 3. yi3 minus yi2 delta yi2 minus yi1, and then plus, right, with vi3 minus vi2, right, plus with this. Okay. Now, the problem is there exists endogeneity. Let me see. Here 3, 2, yeah. There exists endogeneity in here because yi2 here will be correlated with vi2 here because they are in the same year. Right? Remember your original model that when you write yit equal to delta yit minus 1 plus mu I plus vit depend on this, right? So which means yi2 depends on this error term. So you have endogeneity. So you have correlation between this new independent variable with this new error term, right? And that's why you have to instrument this. And what instrument that you use for this one will be yi1, the value from here. Yep. Yep. yi1, the value from there. Because why yi1? Because this value is correlated with this through this term, but it will never correlate with these two. Why? Because y happened in year 1, this error term in year 2 and year 3. So they are not correlated. The new error term. Okay? So you can use this to be the instruments. And when you go to year 4, yi4 minus yi3 equal to delta yi3 minus yi2 plus vi4 minus vi3. Again, we have to get the instrument for this because this term is correlated with this. So what would be the instruments? They suggest yi2 because yi2 correlated with this and not correlated with this. But Arena and Bond suggested why you stop at yi2. You can use two instruments, yi1 also. Right? You can use yi1, which means that yi1 is correlated with this through this. Right? So which means you use internal instruments going to the past values. Now, you think in terms of this case, what happened? If you have 5 years, you use yi3, yi2, yi1. Right? If you have 6 years, your instrument will expand. And the way that the number of instruments increase will be exponential. Because if you have 3 years, only one instrument. If you have 4 years, you have 3. And you have 5 years, you have 6. Right? You have 6 years, you have 10. And you have 15. Right? So sometimes, something that I always ask, right? If you have 20 years of your data, how many instruments that you use? Right? So you look at, you start from 3, right? At leg 3, you have 1. Leg 4, you have 3. 4 years, 5 years. You add with 3, you have 6, right? And then you have 10, and you have 15, and you have 21, right? And you have 28, for example, 5, 6, 7, 8, 9, 10, and 10 you have, you add 6, 7, you have 8, 36. Now you have 10 more to go, right? 8, you add 9 and 40. You have 20 years, how many instruments? It means that you may run into the problem of too many instruments. And Rootman have written on the problem of too many instruments that you have to be aware of. Right? So that's why the ideal case for dynamic panel, the ideal case, when you have T less than 10, that ideal. When you have T more than 10, with N, especially with N smalls, then you have to be wary of this instrument that you use, right? When you have to see, it's like you have one problem here, and you try to fix with so many different things. The problem may not be fixed because you try to do a lot of things to fix, too many, right? You want to put a picture on the wall, for example, you need only one nail. You put 100 nails in there. Why? Too many instruments putting in. It may damage your picture. And the same thing here, it may damage your model itself. Why? You have the problem of too many instruments. And that's why when we run GMM, not only all the assumptions that we have made, we have to be careful about the number of instruments. Right? Now, some of you have run Stata, for examples. Right? You can see exactly when they give you the test statistic, they will say this statistic is not robust if the instruments more than the number of cross-sectional units. So which means that statistic cannot be used, basically. So you have to be careful in terms of the instruments, because GMM use internal instruments deep into the past. If you have 20 years, as I mentioned, you can count on your own. Your instrument can be hundreds. Right? And this is only one endogenous variables. Imagine if you have more than one endogenous variables. Right? You are going to have double instruments. There will be a lot in terms of the instruments that you use. Right? So these are basically the way that we the way that we understand the instrument that has been used. Right? We use instrumental variable, but we have to be careful on counting the instrumental variable techniques. Right? So, yeah.
And number 4, Prof, like 4, it's y I3 minus y I2 and then plus VI4 minus VI3, right?
Yeah.
And you mentioned that the V, the brackets, the last one, I4 minus VI3 is replaced by YI2, right? The IV.
Yeah, no, this one.
No, the error term. The error term you replace with the IV, right? Which one did you replace with the IV?
This one. These are with YI2.
Oh, okay.
This term instrumented with this. They are correlated, but this term is not correlated with this, and that's the requirement.
Okay, and YI1 also.
YI1 can be used because YI1 is correlated with the term that you have here, and the term that you have here is correlated with the term here through this. They are linked between them. Because YI1 will be correlated with this. It means that this also will be correlated with this. So but they are not correlated with the future value of error term.
So there are two instruments that is used.
Yeah, right? For year 4, there are 2 instruments.
Okay.
For year 5, you are going to have 3 instruments.
But it is up to us to, or we can set the starter. We can use the one or
these are the baseline starter.
Or the default one.
The default one.
Oh, okay.
When you run them, you are going to get instruments. Default one go to deep into the past. So this is default that you get. So you have to understand when you get instrument where it come from. As I said, if you have 10 years, for Y alone, for lag dependent variable, you have to have 36 instruments. And plus with other independent variable, you may have 40, 60 instruments. It means that if you have longer years, your instrument will be big, huge. And the problem with big instruments is basically it can also bias the results. It's go back to the original reason we run regressions. We want to get unbiased results. Right? Now we may get biased results. Right? So these are things that if we understand the theoretical foundations, we would be very careful when we try to ask ourselves, do we have too many instruments, for examples? Right? And that's why sometimes I ask about N. I ask about instruments. Because the suggestion given by Rudmans, J here, the number of instruments must be less than the number of N. Right? You have 57 OIC countries. The famous sample that we use, OIC countries. And sometimes less because of data. Right? And we have 20 years of data, maximum. 10 years, 36. Imagine 20 years, it can be more than hundreds. When you have hundreds, it's more than 57. It's not a good modeling. Right? So that's why you have to be careful when you try to models.
So that means we cannot use longer data.
It means two things. Right? It means two things. As I said, the ideal case for GMM is 10 or less. That ideal. If you have more, you still can use GMM, but you have to limit the instruments.
And that cannot be done in Stata.
It can be done, yes. I will show you how to do it. Right? This limiting the instrument suggested by Rudman 2009. Right? When you run using Stata, which one you use? You use XTA bond or XTA bond 2?
XTA bond.
XTA bond 2, right? XTA bond 2 allow you to limit the instruments. Which means that, for examples, the Stata by default, right? Yes.
No, it's
Now, default setting, they will give you instrument up until the pass. You can limit the instrument only up until one leg in the pass. You don't have to use all. You can tell Stata, okay, I want to limit the instrument so that instrument will not become big. So you can do that in Stata. But the idea is this, right? As I mentioned, from statistical theory, we have to check the number of instruments so that there are not too many. Right? And that's why you have to read the article by Rudman 2009. The title of the article, The Problem of Too Many Instruments. Yeah, you quote that, right? But still you violate the instruments.
Well, he can do it. He can do it. So they didn't limit anyway, right?
Yeah,
it's one of the right?
Yeah.
We have to use.
So XTA bond 2 allow you to limit the instruments.